June 20th, 1943, 03:15 hours. River Orne, 12 kilometers east of Caen, France. The pre-dawn mist hung heavy over the dark water, as Lieutenant Colonel John Churchill crouched motionless in the reeds beside the murky riverbank, his blackened face barely visible beneath the canopy of overhanging willow branches. In his mud-stained hands, he clutched what appeared to be an innocent yellow rubber duck, the kind that middle-class British children had played with in bathtubs before the war transformed such simple pleasures into distant memories of peacetime normalcy. To any casual observer, even a trained German sentry scanning the riverbank with night vision equipment, the object would appear to be nothing more than a children's bath toy that had somehow found its way into the French countryside during the darkest days of Nazi occupation. Perhaps a refugee child had dropped it during the desperate flight westward in 1940, when German panzers swept across the Low Countries. Perhaps it had been abandoned when a family was forced to leave their home during one of the countless deportations that had emptied entire villages throughout occupied France. Perhaps it was simply industrial refuse from one of the toy factories that had been converted to military production under German supervision. But this was no ordinary children's toy floating innocently in the waters of occupied Europe. This was explosive device Mark 7, officially designated by the War Office as a covert aquatic demolition system, but known throughout the British Special Operations Executive by its operational code name, Operation Mallard. Hidden within the duck's hollow plastic body, carefully sealed against water infiltration and protected by multiple layers of waterproof coating, was 8 ounces of composition C3 plastic explosive, enough destructive power to destroy a concrete bridge support, sink a heavily loaded patrol boat, or eliminate an entire German machine gun nest along with its crew and ammunition supplies. The explosive charge was surrounded by precisely engineered shrapnel designed to maximize anti-personnel effectiveness while providing fragmentation patterns that could damage equipment and infrastructure far beyond the immediate blast radius. Steel ball bearings, each one carefully counted and positioned to optimize destructive coverage, would create a lethal zone extending more than 50 meters from the point of detonation. The shrapnel pattern had been calculated using mathematical models developed specifically for duck bomb applications, ensuring maximum effectiveness against both human targets and military equipment that might be present in the target area. The detonation mechanism concealed within the duck's body represented months of engineering development by Britain's most skilled ordnance specialists. The timer device, no larger than a pocket watch but engineered to function reliably after days of water exposure, could be set for delays ranging from 30 minutes to 72 hours. Magnetic proximity sensors would activate automatically when the device approached steel structures such as ships, bridges, or harbor installations. Contact fuses provided immediate detonation capability when precise placement against specific targets was required for mission success. This was one of the most psychologically devastating weapons ever deployed against German forces during World War II, a device so insidious in its innocent appearance that it would fundamentally alter the behavior of Wehrmacht soldiers throughout occupied Europe. In the 18 months following its first operational deployment, these innocuous floating ducks would account for more than 200 confirmed kills of German personnel, while destroying dozens of strategic targets throughout the Nazi Empire. More significantly, the psychological impact of never knowing which innocent objects might conceal deadly explosive charges would force German forces to waste enormous quantities of ammunition, shooting at harmless debris, while suffering nervous breakdowns when confronted with environments where any familiar item might bring instant death. Wehrmacht soldiers would develop such intense paranoia about seemingly harmless floating objects that they would shoot at every piece of debris that approached sensitive installations, waste thousands of rounds of precious ammunition on genuine children's toys that posed no threat, and suffer psychological breakdowns when confronted with operational environments where any innocent item might conceal an explosive device powerful enough to kill everyone within a 50-meter radius. The mere possibility that rubber ducks might contain explosives would create anxiety disorders among German personnel that persisted long after the immediate threat had been neutralized through defensive countermeasures. German commanders would be forced to implement security procedures that required detailed investigation of all floating materials before ships could approach harbor installations, slowing critical supply operations while consuming manpower that was desperately needed for combat operations against advancing Allied forces. Standing orders would require soldiers to destroy any unidentified floating objects before they could reach sensitive areas, procedures that consumed enormous quantities of ammunition while requiring constant vigilance from personnel who were already stretched thin by the demands of defending thousands of kilometers of coastline against potential Allied invasion. But the weapon that would terrorize German forces from Norway to Greece began not with military planning or strategic requirements, but with a chance observation made by Captain Geoffrey Appleyard during a reconnaissance mission in occupied Denmark. Appleyard had noticed that German sentries paid no attention to debris floating in harbors and rivers, creating opportunities for covert approaches that conventional infiltration methods could not achieve. The insight that enemy soldiers ignored familiar, harmless objects would evolve into one of the most innovative psychological warfare campaigns of the 20th century. The duck bombs that would earn the grudging respect of German intelligence services represented far more than clever camouflage or tactical innovation. They embodied a fundamental principle of unconventional warfare that exploited enemy assumptions and preconceptions to achieve results that conventional weapons could not accomplish. The story of how British commandos transformed children's toys into instruments of terror reveals the intersection of psychological warfare and explosive technology that characterized some of the most effective special operations of World War II. To understand why rubber ducks became weapons of war, you must first understand the strategic situation that confronted British Special Forces in 1942, and why conventional sabotage techniques had proven inadequate against German defensive measures that made traditional commando operations increasingly dangerous and difficult to execute successfully. By the summer of 1942, German occupation forces throughout Europe had adapted comprehensively to British commando tactics that had initially achieved spectacular successes through surprise, audacity, and the exploitation of German unpreparedness for unconventional warfare operations. The early raids that had terrorized German garrisons from Norway to North Africa and destroyed strategic targets throughout the Nazi Empire were becoming increasingly difficult to execute as Wehrmacht commanders implemented sophisticated security measures specifically designed to counter British special operations techniques that had proven so devastatingly effective during the first 3 years of the war. The German response to British commando operations had evolved through painful experience gained from analyzing successful raids, while interrogating captured personnel and studying equipment that had been abandoned during failed missions. Coastal defenses throughout occupied Europe were systematically strengthened with additional patrols, searchlights, obstacle systems, and early warning networks that made seaborne infiltration extraordinarily hazardous for even the most experienced special operations teams. Harbor installations that had previously been vulnerable to small-scale attacks were now protected by multiple layers of security that included underwater obstacles, patrol boats, constant surveillance, and rapid response forces positioned to converge on any location where British forces might attempt to establish a foothold. German intelligence services had conducted detailed analysis of captured British equipment to understand the capabilities and limitations of specialized tools, weapons, and explosive devices that had been used in successful commando operations. Interrogation of captured personnel provided insights into training methods, operational procedures, and tactical doctrines that enabled German commanders to develop specific countermeasures against British infiltration techniques. Security protocols were established that required German soldiers to investigate any unfamiliar items that appeared in sensitive areas, leading to the discovery and neutralization of conventional sabotage attempts before they could achieve their intended objectives. The sophistication of German defensive measures had increased dramatically throughout 1941 and 1942, as experienced commanders learned to anticipate British operational patterns and deploy countermeasures that eliminated many of the tactical advantages that had made early commando raids so successful. Communication networks enabled immediate coordination between defensive units stationed throughout occupied territories, while air support could be summoned within minutes to engage commando forces that had been detected during their infiltration or extraction phases. Quick reaction forces equipped with armored vehicles and heavy weapons were positioned strategically throughout critical areas to respond rapidly to any indication of British special operations activity. The mathematical precision with which German defenses had been organized reflected the analytical approach that characterized Wehrmacht planning throughout the war. Patrol schedules were randomized to prevent British reconnaissance teams from identifying predictable patterns that could be exploited for timing infiltration operations. Searchlight coverage was coordinated to eliminate blind spots that might provide concealment for approaching commandos. Obstacle placement was calculated to channel potential attackers into predetermined killing zones where concentrated defensive fire could eliminate entire teams before they could achieve their mission objectives. German defensive doctrine had also evolved to emphasize rapid response capabilities that could overwhelm small commando teams through superior numbers and firepower rather than attempting to prevent infiltration entirely. The reality of defending thousands of kilometers of coastline made absolute security impossible, but rapid reaction forces could engage detected infiltrators before they could complete their sabotage missions and escape to friendly territory. This approach forced British planners to develop extraction procedures that were as complex and dangerous as the initial infiltration, significantly increasing mission complexity while reducing the probability of successful completion. The psychological impact of increasingly sophisticated German countermeasures was creating serious problems for British special operations recruitment and training programs. Commando units were suffering casualty rates that approached 50% on some missions, making it extremely difficult to maintain experienced personnel while recruiting and training replacement personnel who possessed the specialized skills necessary for complex operations behind enemy lines. The knowledge that German defenses were becoming more effective created stress and hesitation among commando personnel, who understood that mission failure often resulted in capture, torture, and execution, rather than the possibility of escape and evasion that had characterized earlier periods of the war when German security measures were less comprehensive. Veterans of successful early commando operations reported that the psychological pressure of operating in increasingly hostile environments was affecting unit morale and combat effectiveness even among the most experienced personnel. The knowledge that German forces were actively searching for British infiltrators using sophisticated detection methods created anxiety that made covert movement more difficult, while increasing the probability of detection through nervous behavior or tactical errors. The cumulative stress of multiple operations in progressively more dangerous environments was causing psychological casualties that reduced the pool of experienced personnel available for future missions. Training programs for new commando personnel were struggling to prepare recruits for operational environments where German countermeasures had eliminated many of the tactical advantages that had made early special operations successful. Infiltration techniques that had proven effective in 1940 and 1941 were becoming suicidal when attempted against defensive systems that had been specifically designed to counter such approaches. Equipment that had provided technological advantages over German forces was becoming obsolete as enemy countermeasures eliminated the effectiveness of specialized tools and weapons that had been developed for covert operations. Captain Geoffrey Appleyard, commanding a reconnaissance team from No. 4 Commando that specialized in deep penetration missions behind German lines, had been studying these evolving challenges during intelligence-gathering operations that took him into the heart of German-occupied territory throughout the spring and early summer of 1942. Born in Leeds on July 13, 1916, To a family that valued both academic achievement and practical problem-solving, Appleyard had distinguished himself as one of Britain's most innovative special operations officers through his development of infiltration techniques that emphasized stealth, misdirection, and psychological manipulation rather than direct confrontation with superior enemy forces. His educational background included engineering studies at Cambridge University that had provided him with the technical knowledge necessary to understand complex mechanical systems while developing innovative solutions to seemingly impossible problems. This engineering perspective proved invaluable when analyzing German defensive measures to identify vulnerabilities that could be exploited through unconventional approaches that did not conform to established military doctrine. Appleyard's ability to think systematically about tactical problems while maintaining creativity and developing solutions had earned him recognition throughout British special operations community as one of the most promising young officers in the service. His early military career had included conventional infantry training that provided a solid foundation in basic military skills before he volunteered for special operations duty that required additional training in specialized techniques such as demolitions, sabotage, close-quarters combat, and covert movement in hostile territory. The combination of conventional military training and specialized special operations skills had given Appleyard the comprehensive background necessary to understand both the capabilities and limitations of German defensive systems while developing innovative approaches that could overcome enemy countermeasures through unexpected methods. His background in engineering and amateur psychology had given him unique insights into human behavior patterns that proved invaluable when developing methods for avoiding detection during covert operations in areas where German security forces maintained constant surveillance. Appleyard understood that German sentries, like soldiers throughout history, developed routine scanning patterns and attention focuses that created predictable blind spots in their surveillance coverage that could be exploited by infiltrators who understood the psychological factors that influenced human observation patterns. Objects that appeared familiar and harmless were typically ignored during casual observation, while unusual or obviously military items immediately attracted attention that could compromise entire operations before they could achieve their intended objectives. Captain Geoffrey Appleyard, commanding a reconnaissance team from No. 4 Commando, had been studying these problems during intelligence-gathering missions that took him deep into German-occupied territory throughout the spring of 1942. Born in Leeds on July 13, 1916, Appleyard had distinguished himself as one of Britain's most innovative special operations officers through his development of infiltration techniques that emphasized stealth and misdirection rather than direct confrontation with superior enemy forces. His background in engineering and amateur psychology had given him insights into human behavior patterns that proved valuable when developing methods for avoiding detection during covert operations. Appleyard understood that German sentries, like soldiers throughout history, developed routine scanning patterns and attention focuses that created predictable blind spots in their surveillance coverage. Objects that appeared familiar and harmless were typically ignored during casual observation, while unusual or obviously military items immediately attracted attention that could compromise entire operations. The breakthrough observation came during a reconnaissance mission to evaluate German defenses around the port of Esbjerg in occupied Denmark. Appleyard's team had spent 3 days studying patrol patterns and security procedures from concealed positions along the harbor perimeter when he noticed that German sentries consistently ignored floating debris that accumulated around pier installations. Empty bottles, pieces of wood, fishing net floats, and other common harbor refuse drifted past guard positions without attracting any attention from personnel who were focused on detecting human threats rather than environmental clutter. More significantly, Appleyard observed that floating objects could approach sensitive installations much closer than human swimmers or small boats without triggering defensive responses. The psychological tendency to dismiss familiar, everyday items as harmless created opportunities for covert delivery of explosive devices that conventional infiltration methods could not achieve. A properly camouflaged explosive device might float directly against its target without arousing suspicion until detonation revealed its true nature. The concept that emerged from this observation was elegantly simple, yet profoundly innovative. Explosive devices disguised as common floating objects could be deployed upstream from target installations and allowed to drift with natural water currents until they reached positions where timer mechanisms or proximity fuses would trigger detonation. The delivery method required no human presence near the target area, eliminating the risks associated with infiltration and escape that had made conventional sabotage operations increasingly hazardous. But transforming this concept into practical weapons required solving technical challenges that had never been attempted by military engineers. The camouflage had to be perfect enough to withstand casual observation by trained military personnel, while concealing explosive charges sufficient to damage hardened military targets. The devices needed to be waterproof and reliable under conditions that included temperature variations, saltwater exposure, and mechanical impacts that might occur during transit to target areas. Most challenging of all, the weapons had to function predictably after extended periods, floating in unpredictable water currents that might carry them far from their intended targets. Appleyard presented his preliminary ideas to the Special Operations Executive Headquarters in Baker Street during September 1942, requesting authorization and technical support to develop what he called floating camouflage explosives. The initial response was cautiously positive, recognizing the potential value of delivery methods that did not require direct human exposure to enemy defensive fire. SOE had been searching for innovative sabotage techniques that could achieve results against hardened targets without the casualty rates associated with conventional commando operations. The development program that emerged from Appleyard's initial concept involved collaboration between the Special Operations Executive's Research Section, explosive specialists from the Royal Ordnance Factory, and military psychologists who studied German behavior patterns to optimize camouflage effectiveness. The team faced extraordinary technical challenges requiring innovative solutions to problems never encountered in previous weapons development programs. The selection of rubber ducks as optimal camouflage resulted from extensive analysis of objects that appeared frequently in European waterways without attracting military attention. Children's toys remained common throughout occupied territories, despite wartime shortages, and their presence was easily explained by normal civilian activity. Psychological studies indicated that military personnel experienced cognitive dissonance when confronted with items that seemed inappropriate for military contexts, leading to subconscious dismissal rather than careful investigation. The rubber duck design offered practical advantages ideal for explosive applications. The hollow construction provided ample space for explosive charges while maintaining buoyancy characteristics that enabled predictable floating behavior. The bright yellow color ensured visibility during deployment while appearing innocuous to enemy observers. The familiar shape created immediate recognition that reinforced the harmless toy association essential for avoiding detection. The explosive component presented unique engineering challenges requiring entirely new techniques for waterproof explosive containment that could withstand extended exposure to hostile environments while maintaining reliable detonation capability. Standard military explosives were too unstable for extended water exposure, while conventional waterproofing methods added weight that compromised floating characteristics essential for effective deployment against targets accessible only through water routes. The solution involved using composition C3 plastic explosive, developed specifically for special operations applications where conventional explosives proved inadequate. C3 was inherently stable and waterproof, while providing maximum destructive power in minimum volume. The compound remained stable under temperature variations ranging from Arctic conditions to tropical heat while maintaining sensitivity to electrical detonation that could be triggered reliably by timer mechanisms or proximity sensors. Each duck bomb contained precisely 8 ounces of C3 plastic explosive, a quantity determined through extensive testing to provide optimal balance between destructive capability and device weight that affected floating performance. This amount provided sufficient explosive power to destroy small boats up to 30 feet in length, damage larger vessels enough to render them inoperable, demolish bridge supports or harbor installations, or eliminate defensive positions along with their personnel and equipment within a blast radius, extending more than 50 meters from the detonation point. The explosive charge was surrounded by carefully designed shrapnel assemblies that increased anti-personnel effectiveness while providing fragmentation patterns that could damage equipment and infrastructure beyond the immediate blast area. Steel ball bearings, each precisely sized and positioned according to mathematical models predicting optimal fragmentation patterns, were embedded in matrices that directed shrapnel in predetermined directions, maximizing coverage of target areas while minimizing wasted energy. The entire explosive assembly was sealed within multiple layers of waterproof compartments that prevented moisture infiltration during extended water exposure while maintaining precise weight distribution essential for stable floating performance under various environmental conditions. The waterproofing system incorporated redundant sealing mechanisms, ensuring reliability even if individual components failed due to mechanical damage or environmental degradation during extended deployment periods. The detonation mechanisms represented the most sophisticated components of duck bomb systems, requiring engineering precision never attempted for waterproof explosive devices that might operate for extended periods under hostile environmental conditions. Timer devices had to function reliably after hours or days of water exposure while providing accurate delay periods, ensuring detonation occurred when devices reached their intended target areas, despite unpredictable water currents that might carry them far from planned impact points. The timer mechanisms incorporated clockwork movements protected against moisture infiltration while maintaining accuracy under temperature variations and mechanical stresses that would destroy conventional timing devices. Proximity sensors needed to distinguish between legitimate target installations and random environmental contacts that might occur during transit through waterways containing debris, marine life, or other objects that could trigger premature detonation if sensor systems were not properly calibrated. Testing of prototype duck bombs began in December 1942 at isolated facilities in Scotland, where explosive characteristics could be evaluated without compromising operational security. The test program involved deploying devices in various water conditions to validate floating performance, detonation reliability, and camouflage effectiveness under simulated operational conditions. Testing revealed minor problems with buoyancy control and timer waterproofing that required design modifications before the weapons could be approved for operational use. Composition C3 had been developed through extensive research programs that combined the explosive power of traditional military compounds with the stability and handling characteristics necessary for covert operations, where weapons might be subjected to environmental conditions that would render conventional explosives unreliable or dangerous to handle. The compound remained stable under temperature variations ranging from Arctic conditions to tropical heat, while maintaining sensitivity to electrical detonation that could be triggered reliably by timer mechanisms or proximity sensors that detected the presence of enemy targets within lethal radius of the explosive device. The manufacturing process for C3 required specialized facilities and quality control procedures that ensured consistent performance characteristics while maintaining the extraordinary security measures necessary to prevent German intelligence services from learning about the new explosive compounds that were being developed for British special operations. Each batch of explosive material was individually tested under controlled conditions that simulated the environmental stresses that duck bombs would encounter during operational deployment, ensuring that explosive performance remained consistent regardless of water temperature, salinity levels, or mechanical impacts that might occur during transit to target areas. Each duck bomb contained precisely 8 ounces of C3 plastic explosive, a quantity that had been determined through extensive testing to provide optimal balance between destructive capability and device weight that affected floating performance. 8 ounces of C3 provided sufficient explosive power to destroy small boats up to 30 feet in length, damage larger vessels enough to render them inoperable, demolish bridge supports or harbor installations, or eliminate defensive positions along with their personnel and equipment within a blast radius that extended more than 50 meters from the point of detonation. The explosive charge was surrounded by carefully designed shrapnel assemblies that increased anti-personnel effectiveness while providing fragmentation patterns that could damage equipment and infrastructure beyond the immediate blast area where explosive effects alone might be insufficient to achieve mission objectives. Steel ball bearings, each one precisely sized and positioned according to mathematical models that predicted optimal fragmentation patterns, were embedded in matrices that directed shrapnel in predetermined directions, that maximized coverage of target areas while minimizing wasted energy in directions where no significant targets were likely to be present. The shrapnel design incorporated lessons learned from previous British explosive devices while adapting fragmentation principles to the unique requirements of duck bomb operations, where targets might include personnel, equipment, or infrastructure that required different approaches to achieve maximum destructive effectiveness. The ball bearing sizes were selected to provide optimal penetration characteristics against various target types, including human personnel, vehicle armor, building materials, and marine equipment that might be encountered in harbor installations or along waterways where duck bombs would be deployed. The entire explosive assembly was sealed within multiple layers of waterproof compartments that prevented moisture infiltration during extended periods of water exposure, while maintaining precise weight distribution that was essential for stable floating performance under various environmental conditions. The waterproofing system incorporated redundant sealing mechanisms that ensured reliability even if individual components failed due to mechanical damage or environmental degradation that might occur during extended deployment periods. Testing of waterproof sealing systems involved subjecting prototype devices to environmental conditions that exceeded expected operational requirements, including extended submersion in salt water, temperature cycling that simulated Arctic and tropical conditions, and mechanical stress testing that replicated impacts that might occur during deployment or transit to target areas. These tests revealed design requirements for sealing materials and construction techniques that had never been applied to military explosive devices, requiring development of new manufacturing processes that could maintain waterproof integrity while meeting production schedules that supported operational requirements. The detonation mechanisms represented the most sophisticated components of duck bomb systems, requiring engineering precision that had never been attempted for waterproof explosive devices that might operate for extended periods under hostile environmental conditions. Timer devices had to function reliably after hours or days of water exposure, while providing accurate delay periods that ensured detonation occurred when devices had reached their intended target areas, despite unpredictable water currents that might carry them far from planned impact points. The timer mechanisms incorporated clockwork movements that were protected against moisture infiltration, while maintaining accuracy under temperature variations and mechanical stresses that would destroy conventional timing devices. The clockwork systems were manufactured to tolerances that exceeded those required for precision timepieces, while incorporating materials that resisted corrosion from saltwater exposure that would rapidly degrade standard clock mechanisms under operational conditions. Proximity sensors needed to distinguish between legitimate target installations and random environmental contacts that might occur during transit through waterways that contained debris, marine life, or other objects that could trigger premature detonation if sensor systems were not properly calibrated. The magnetic proximity fuses were designed to activate only when duck bombs approached steel structures such as ships, bridges, or harbor installations that contained sufficient ferrous metal to generate magnetic field disturbances that exceeded predetermined threshold levels. The fusing systems required fail-safe mechanisms that prevented accidental detonation during handling, transport, or deployment operations while ensuring reliable activation when devices reached their intended targets under operational conditions that might vary significantly from controlled testing environments. Multiple redundant safety systems were incorporated to prevent premature detonation while maintaining sensitivity to legitimate activation signals that indicated the presence of appropriate targets within effective range of explosive charges. The final design incorporated multiple fusing options that could be selected based on specific mission requirements. Timer mechanisms provided delays ranging from 30 minutes to 72 hours, enabling deployment of duck bombs far upstream from target areas while ensuring detonation occurred at predetermined times regardless of water current variations. Magnetic proximity fuses activated when the devices approached steel structures such as ships, bridges, or harbor installations, providing automatic target recognition that eliminated timing uncertainties. Contact fuses triggered immediate detonation when duck bombs struck specific targets, enabling precision attacks against small installations that required exact placement for effective damage. Testing of prototype duck bombs began in December 1942 at isolated facilities in Scotland where explosive characteristics could be evaluated without compromising operational security. The test program involved deploying devices in various water conditions to validate floating performance, detonation reliability, and camouflage effectiveness under simulated operational conditions. Testing revealed minor problems with buoyancy control and timer waterproofing that required design modifications before the weapons could be approved for operational use. The psychological warfare aspects of duck bomb operations were considered equally important as their explosive effectiveness. Psychologists predicted that German forces would develop intense paranoia about seemingly innocent objects once the true nature of duck bombs became apparent through operational use. This psychological impact would force enemy personnel to waste time and ammunition investigating harmless debris while creating stress and fear that degraded combat effectiveness even when no actual duck bombs were present in an area. The production phase involved manufacturing 500 duck bombs during the early months of 1943 using specialized facilities that maintained extraordinary security to prevent German intelligence from learning about the new weapons. Each device was individually tested and calibrated to ensure consistent performance, while production records tracked serial numbers and deployment assignments to enable assessment of operational effectiveness. The manufacturing process required precision assembly techniques that had never been applied to camouflaged explosive devices. Training programs for commando units that would deploy duck bombs emphasized deployment techniques that maximize the probability of successful target engagement while minimizing risks to personnel conducting the operations. Commandos learned to calculate water current speeds and directions to predict duck bomb drift patterns. They studied timing procedures that ensured devices would reach target areas when security was minimal and defensive attention was focused elsewhere. They practiced covert deployment methods that enabled duck bomb release without detection by enemy patrols or surveillance systems. The first operational use of duck bombs occurred during Operation Starkey in March 1943, when 12 devices were deployed against German shipping in the port of Cherbourg. The mission involved a two-man commando team that infiltrated to within 3 kilometers of the harbor and released the duck bombs into the River Divette during the early morning hours when water currents would carry them into the main harbor area during peak shipping activity periods. The psychological impact of this initial attack exceeded all expectations. German harbor patrol personnel discovered the first duck bomb when it became entangled in anchor chains of a transport vessel. Initial investigation revealed the explosive device concealed within what appeared to be a children's bath toy, creating immediate alarm among German security forces who began systematic searches for additional devices. The discovery of 11 more duck bombs floating throughout the harbor created panic among German personnel, who suddenly realized that any innocent object might conceal deadly explosives. The German response to the duck bomb discovery involved massive security operations that disrupted harbor activities for more than a week, while personnel searched every floating object within a 5-kilometer radius of Cherbourg. German soldiers shot hundreds of rounds of ammunition at floating debris, genuine children's toys, pieces of wood, and other harmless objects that might conceivably hide explosive devices. The psychological effect of uncertainty about which objects were dangerous created stress and paranoia that persisted long after the immediate threat had been neutralized. Intelligence reports from French resistance sources indicated that German morale in the Cherbourg area had been severely affected by the duck bomb incident. Soldiers who had previously ignored environmental clutter now investigated every unusual object with extreme caution. Harbor operations slowed significantly, as security procedures required detailed inspection of all floating materials before ships could approach pier installations. The fear that any innocent item might explode created psychological pressure that degraded German combat effectiveness throughout the region. The success of Operation Starkey led to expanded duck bomb deployments throughout German-occupied Europe during the summer and autumn of 1943. Operations against harbor installations in Norway, Denmark, Belgium, and southern France achieved similar psychological effects while causing significant material damage to German shipping and infrastructure. Each successful deployment reinforced German paranoia about camouflaged explosives while demonstrating British capability to strike targets that had previously been considered secure from commando attack. The German countermeasures that developed in response to duck bomb attacks involved systematic destruction of all floating debris in sensitive areas, regardless of apparent harmlessness. Standing orders required soldiers to shoot any unidentified floating objects before they could approach critical installations. These procedures consumed enormous quantities of ammunition, while requiring constant vigilance from personnel, who had to evaluate potential threats among normal environmental clutter. The psychological burden of maintaining such intensive security created fatigue and stress that affected German defensive capabilities throughout occupied territories. German intelligence services eventually captured intact duck bombs and developed technical understanding of their construction and operation. But this knowledge provided limited protection against psychological effects that had already been established. Even when German personnel knew that rubber ducks might contain explosives, they could not distinguish between genuine threats and harmless toys without detailed investigation that disrupted normal operations. The uncertainty about which objects were dangerous maintained psychological pressure that persisted throughout the remainder of the war. The most significant duck bomb operation occurred during preparations for the Normandy invasion, when coordinated attacks against channel ports were designed to disrupt German defensive preparations, while creating maximum psychological impact among coastal garrison forces. Operation Duckling involved simultaneous deployment of more than 200 duck bombs against harbor installations from Le Havre to Ostend, creating the impression of massive British infiltration capabilities that forced German commanders to divert resources from beach defenses to protect rear area installations. The timing of Operation Duckling was carefully coordinated with other deception operations that were designed to convince German commanders that the main Allied invasion would target the Pas-de-Calais region rather than Normandy. The concentration of duck bomb attacks in channel ports north of the actual invasion area reinforced German preconceptions about Allied intentions while demonstrating British special operations capabilities that seemed to reach throughout occupied Europe. The psychological effect of simultaneous attacks at multiple locations created the impression of coordinated operations involving hundreds of commandos rather than the small teams that actually conducted the missions. Intelligence analysis following Operation Duckling revealed that German defensive preparations had been significantly disrupted by the psychological impact of duck bomb attacks. Coastal artillery units diverted personnel to search for infiltrating commandos who might be conducting reconnaissance for additional attacks. Harbor defenses were strengthened at the expense of beach obstacles that were essential for repelling amphibious assaults. Communication networks were disrupted by false alarms and security alerts that prevented efficient coordination of defensive operations. The material damage caused by duck bomb explosions was significant but secondary to psychological effects that influenced German behavior throughout the final year of the war. More than 40 vessels were damaged or destroyed by duck bomb attacks, while harbor installations, bridges, and communication facilities suffered extensive damage that required repairs using resources needed for military production. The economic impact of defensive measures implemented to counter duck bomb threats consumed additional resources while reducing efficiency of transportation and communication systems throughout occupied Europe. Captain Geoffrey Appleyard, the architect of duck bomb operations, was killed in action during a reconnaissance mission in Sicily before he could see the full impact of his innovative weapons concept. His death on July 30, 1943, deprived British Special Forces of one of their most creative tactical thinkers. But the duck bomb program continued under other commanders who recognized the strategic value of psychological warfare techniques that achieved results far beyond their apparent capabilities. The production and deployment of duck bombs continued throughout 1944, as German defensive measures created new opportunities for psychological warfare operations. Special operations units developed increasingly sophisticated variations of the basic duck bomb concept, including devices disguised as bottles, fishing floats, pieces of driftwood, and other common floating objects that expanded the range of camouflage options available for specific operational requirements. The technical evolution of duck bomb design incorporated lessons learned from operational experience, while addressing German countermeasures that had been developed to detect and neutralize the devices. Improved waterproofing extended operational life under adverse conditions. Enhanced explosive charges increased destructive effectiveness against hardened targets. More sophisticated fusing systems provided greater reliability and precision timing that improved target engagement probability. The psychological warfare principles demonstrated by duck bomb operations influenced other aspects of British special operations throughout the remainder of World War II. The concept of exploiting enemy assumptions and preconceptions became fundamental to deception operations that achieved strategic results through misdirection rather than direct confrontation. The understanding that psychological impact could be more significant than material damage-shaped planning for operations that prioritized enemy morale degradation over physical destruction of military targets. German documentation captured after the war revealed the profound psychological impact that duck bomb operations had achieved among Wehrmacht personnel throughout occupied Europe. Soldiers developed intense anxiety about seemingly innocent objects that might conceal deadly explosives. Standing orders requiring investigation of all potentially suspicious items created workload increases that affected operational efficiency. The uncertainty about which objects represented genuine threats maintained constant stress that degraded combat performance and unit cohesion throughout German forces. The cost-effectiveness of duck bomb operations represented one of their most significant strategic advantages. Each device cost approximately £10 to manufacture and deploy, yet achieved psychological effects that required thousands of pounds worth of German defensive measures to counteract. The disproportionate impact of relatively simple weapons demonstrated the strategic value of innovative approaches that exploited enemy vulnerabilities rather than attempting to overcome superior numbers and firepower through conventional methods. Post-war analysis by military historians has identified duck bomb operations as among the most successful psychological warfare campaigns of World War II. The combination of material damage and psychological impact achieved results that influenced German behavior throughout the final 18 months of the European conflict. The innovative approach to camouflaged explosives established precedents for special operations techniques that continue to influence unconventional warfare doctrine throughout the modern era. The legacy of duck bomb operations extends beyond their immediate impact during World War II to encompass broader principles of asymmetric warfare that remain relevant to contemporary military conflicts. The demonstration that simple, inexpensive weapons could achieve strategic effects against sophisticated defensive systems has influenced special operations planning throughout the post-war period. The psychological warfare techniques pioneered through duck bomb deployment continue to shape approaches to unconventional operations that prioritize enemy morale degradation over physical destruction. The rubber ducks that terrorized German forces throughout occupied Europe represented more than clever camouflage or innovative explosive technology. They embodied fundamental principles of unconventional warfare that exploited human psychology to achieve military objectives that conventional weapons could not accomplish. The success of duck bomb operations demonstrated that creativity and innovation could overcome defensive advantages that appeared insurmountable through traditional approaches. Modern special operations forces continue to study duck bomb operations as examples of psychological warfare techniques that achieved disproportionate strategic impact through relatively simple means. The principles of exploiting enemy assumptions, creating psychological uncertainty, and using inexpensive weapons to force costly defensive responses remain fundamental to contemporary unconventional warfare doctrine. The innovative thinking that transformed children's toys into instruments of terror continues to inspire approaches to asymmetric conflicts that emphasize creativity over overwhelming firepower. The British Commandos who deployed rubber ducks against German forces achieved results that influenced the course of World War II while establishing precedents for psychological warfare that continue to shape military thinking 8 decades later. Their innovative approach to camouflaged explosives demonstrated that unconventional thinking could overcome seemingly impossible tactical challenges while achieving strategic effects that conventional operations could not accomplish through superior numbers or firepower alone. That is how British commandos turned toy ducks into weapons of terror through psychological warfare that exploited German assumptions about harmless objects, creating paranoia and fear that degraded enemy combat effectiveness throughout occupied Europe while demonstrating that innovation and creativity could achieve strategic results that conventional weapons and traditional tactics had been unable to accomplish against sophisticated defensive systems.